I think we are starting now. Um, Hi everyone, today we are continuing with the behaviors of the universe, which is necessity for us, and what the world I'm calling for the behaviors is honestly the qualifications of the universe and its own features that is dependent on the time and the material distribution inside of it. And the other parts which are compulsory for us is to continue with the galaxies, the stars, and the other schedule we intend to talk about. So today, the preference of mine is continuing with the bifurcate the eras of the universe, so its own qualifications, and the reason of my doing such a thing is to understand the features and understand that feature about the qualifications of that times. Because at the late times, the situation of the universe is different, and at the present time and the future time is also as well. So to say is something necessary to do such a thing, and after great and auspicious assessments that will be done by us, we will be easily able to understand the nature of the universe and its history at the end of this video. In this way, it's going to be a little bit different and good. So, the preference of mine, as I said in previous minutes, to choose in the present time, right now, and observing the nearby galaxies, and assuming that we are one single point in the universe, like one dot, and we are in star cluster, because it is true, the observational facts are validates and also evidences, honestly evidence, that we are in a local group. The local group that consists of with many types of masses galaxies, with great and enormous values, with great distance between them, and because we know that they are dependent with the gravitational forces. They have mass, they have the atoms inside of it, which are making up the energy and then just pulling together inwards, honestly, towards the center of the mass. So the purpose of ours for today's video is to continue with explaining and examining this kind of issues, which are necessities to understand the behaviors of the universe, because it's expanding, it's stretching out, and as it stretches out, the material distribution inside of it is going to be changing, because we know that nothing is in the universe is stable or constant, but everything is changing and time dependent, or maybe there are changing things which are derivatives, suitable to derivate to time, and this way it's going to be a little bit funny for us, and including many types of formulas and the calculations to understand them. So also, at the end of this video, you will be able to explain everything in the universe and make the equations available for any cases you are in. So it's going to be well and perfectly done. Nice. Okay, we are continuing now and assume that we are at the center of the galaxy, the Milky Way. And the nearby galaxies are around us. We are observing them to understand the behavior, which are dependent. Honestly, the behavior is not one single thing, including many types, so we are looking for the plural pronunciation of it. Behaviors and the dependence of what it depended. I mean, the importance is that we will discuss the other sections, as the book says, not books, I am. It depends on the gravitational forces and its situation. Because just imagine and assume that we are in the center of the galaxies and observing the other galaxies, and just choosing one galaxy which is at the age of the gravitational forces field. I mean, there's a field and there's an object. So this object affects because of the field and gets, or maybe the feels that force on it, which causes the acceleration towards to the center of the mass. Or because we know that it has the kinetical energy because of the orbiting such an orbital. I mean, the galaxy has a circular motion and it has the velocity, and velocity components are very important in this case, because if the velocity value is bigger enough, the escape velocity, the necessity or requirement velocity, that is something necessity to escape from the gravitational forces, what we call it, this maybe another section, are bigger than, I mean, the values of them are bigger than the gravitational forces. Or we can also easily imagine that or explain that with the energy situation, because of the kinetical energy and the value of it, it's bigger. If it is bigger than the gravitational potential energy, what's going to be happen? The galaxy is going to far away, and if the gravitational forces are bigger and the potential energy of gravitation, the value of it is bigger than the kinetical energy the galaxy has, it's going to come and move into the center of the mass. But it's not directly happening because it has the velocity components inward and outward, and the gravitational forces are just occurring towards the object we choose. So it is important to investigate this case. And the other case is important because we will continue with the behavior which are dependent on the space-time curvatures. But this is at the end of this video, because the new modern physics and theories that it is including the space and time is compact, and there are curvatures at the space-time tissue because of the masses and the enormous value of masses causing such a thing. And the reason why we are doing such a thing to investigate, and afterwards we will assess, after various types of assessments, we will infer that the motion of the particle or the galaxy, it doesn't matter what we choose, is doing the behavior, or maybe make it real, and what we are observing, as it is suitable and available for the physics laws we demonstrated. They are all constant, and they have the consistencies. They are consistent together and each other. So it is important to choose the galaxy from the first. And now we are observing the galaxy. I will use the board right now to understand and to illustrate it. I am explaining what we will do in this video. We are just explaining the situation of the galaxy we are observing in the present time, and just the behavior of it. And while we are explaining the behavior, it's going to be far away or pulling into the center because of the gravitational forces, we will demonstrate the Friedmann equations to understand the expanding of the universe and the dependence of material. Why is that important? Because material includes atoms. The density of atoms per unit volume is important, because matter tells space how to curve and space tells matter how to move. This matter is the density, the field or the force on the space-time tissue that creates the curvatures or that bends to the space. And we will continue with it. Demonstrate all the equations we need and require. And the cosmological constant too. And Einstein field equations too. Everything is in this video. So you are welcome, and you are so lucky because I am trying to explain them to understand more clearly, and these are the kind of topics to talk about, and so hard to understand. It's some levels of physics, and the physics interested guys or ladies, doesn't matter, so including many types of calculations, and it's going to be fun because we will talk about observational facts too.